Hello students, today's organic conversion video I am going to discuss two organic conversion, propanone to propene and ethanol to but-2-eneoic acid. Propanone means acetone. So when we want to synthesize propanone to propene, first we have to perform a reduction. In presence of sodium borohydride, acetone gives secondary alcohol which is called isopropanol. Now if we can remove this OH and one hydrogen from this group, we will be getting a double bond here. So that means here we are doing a elimination reaction. For the elimination reaction, either we can use alcoholic KOH followed by heating, or we can add concentrated sulfuric acid with heating. This is elimination reaction. Here the mechanism I have shown here. This carbon oxygen bond breaks, you are getting a positively charged. Now this deprotonation happen, we are getting a double bond. Next one is the ethanol to but-2-eneoic acid. This conversion is quite interesting conversion. Here we can learn many organic chemistry reactions. Here you can see we started the reaction with 2 carbon atoms. We end up with 4 carbon atoms. And we know in organic chemistry, if we want to increase the number of carbon atoms, either we can add cyano group or we can add Grignard reagent. Cyano group we can convert it into carboxylic acid group, and if we add Grignard reagent also, we can increase one more carbon atoms. So here we can see from started with 2, ended up with 4. That means there are 2 steps where we have to introduce 2 extra carbons. So first, this oxidation reaction of ethanol. Here we are not using a strong oxidizing agent like KMnO4 because it will give carboxylic acid directly. So here we have to perform a mild oxidation reaction. For that we are using PCC, we are getting acetaldehyde. Now acetaldehyde reacts with CH3MgBr, we are getting secondary alcohol. Now here you can see we started with 2 carbons, now we have 3 carbons. And this group means this compound, you can see this carboxylic acid group is connected with sp2 carbon. That means first we have to synthesize this part, and then carboxylic acid will be introduced into the sp2 carbon. Now we have a isopropanol, then elimination reaction, we will be getting propene. So now here this carbon we have to add carboxylic acid. So for that we have to introduce cyano group here. To introduce the cyano group, here we have to add some halogens. If we want to introduce halogen in the less substituted carbon of the double bond, we have to perform an anti-Marconi-Curves rule, means we have to follow the anti-Marconi-Curves rule, and for that we need hydrogen HBr and hydrogen peroxide. Bromine will come in this carbon, we are getting this propyl bromide, 1 propyl bromide. Now sodium cyanide, simple SN2, will be getting cyano compound, acidic hydrolysis, cyano will oxidize to carboxylic acid. Next step is that we have to introduce a double bond next to carboxylic acid. So here double bond is between alpha and beta carbon. To introduce a double bond here, first we have to introduce a bromine group here, and that's why we are doing a Hell-Vollert-Zielinski reaction, red phosphorus bromine. Here bromine is coming in the alpha position. Then elimination reaction, we will be getting a double bond here. Then we are getting our final product, but-2-eneoic acid. I hope this explanation is clear to all of you. If you like this video, share it with your friends and subscribe my channel Chemistry Affinity. Thank you for watching it.